What do we typically say water's going to seek? Path of least resistance. So perpendicular to those contours is the path of least resistance. It's not going to run along those contours by any means. Okay. What happens when a cloud rolls by and it leaves 13 feet of snow on the top of the mountain? Where's that snow going to go, or where's the water going to go when the snow melts? Going to go down somewhere, right? So the question is, and one of the things that we can use this to calculate and determine kind of some examples, if I have 13 feet of snow on the top of this mountain, how much water does that equate to? Anybody know? Is it the same every year?
No.
Okay. So 13 feet of snow one year might be 2 inches of rain overall. 13 feet of snow one year might be 2 feet of water in the spring runoff, right? So how does that work, or what are we referring to when we say, well, who cares? It's just snow. It's going to come down. It's going to go somewhere. Where's the snow going to go? Lakes and reservoirs and rivers, right? So if we have 13 feet of snow on any given year, how much storage capacity do we need in the reservoir? Okay, so, but it's going to be different, right? So how do we know how much water is going to be in that snow?
We'll test the snowpack.
That's exactly what we do. We'll test that snowpack. We do hydrological type surveys, right? Where we'll actually test how much, we can determine how much moisture is in that water, right? They're doing snow surveys all winter long. So what do we have to do with our reservoirs that's based on that information? Okay. And so at what point do you open the head gates and start letting the water out? Okay. I mean, is it an exact science? You know, it's really not, because every year is going to be different, right? And if we've got capacity in a particular reservoir and we know what that capacity is, and we know how much water is up on the mountain, and those capacities, the capacity of the reservoir and the amount on the water, or the amount of the snow on the mountain, is greater than the capacity of the reservoir, what do we got to do?
Let some water out the reservoir.
Or move, right? Okay. So the idea is being able to juggle that water coming down off the mountain to fill that reservoir. And at what point do we open the head gates, and at what point do we close the head gates? Okay, to allow that water to come down and fill that reservoir up every year. Site that we want to construct, let's say a road. We're going to pull in Caterpillar's little blade here. And if we build a road, I like my Caterpillar better. If we build a particular road here, what's got to happen with this road? Okay, grade in what way? It's got to have, now you talk about grade, what do you mean by that? Okay, going up. So you're saying that I can't drive a truck up this road like this? And what's the right grade? 10 is the max, right? We can't go any higher than 10%. So, but what we've got to do is, if we've got to get a truck up there, more than likely we're going to figure out a way to get it to the top, right? Using the contours, right? When we take a look at a road and its design, here now we've got a road. We're going to build a house on top of the mountain right here. Okay, we've got a road that's got to get to the top to this house. You with me? Let's go to the top here. All right. What happens? Thank you. What happens when it rains now?
Follow the road down.
Okay, so now we bring our rain cloud in.
We wash out the road some.
Okay. What's going to go on with that road at or when the rain hits that road? Okay. If there's too much, right, that water's going to come right across the road. So what have we got to do? Am I going to slope this road back to the mountain like this? Or am I going to slope it out like this? Okay, because that water's got to go where? Okay. Is there a chance that that water could stay on that road? What's
how you built it?
Okay. Okay, and what's the crown going to do for us? Okay, on a side hill like this, would we put a crown on this road?
No.
What would we want then? Okay, so what would the slope on that road need to be in terms of the mountain? It would all need to go away from the mountain, right? Now if the road up here, now think about this, if the road up here is sloping down, that water's going to hit this road and then that's going to hit it a second time. You see that? Is that a problem? Can it be a problem?
Well, it could if it was excessive rain.
Okay. Again, if we wash out the road, what do we got? We ain't got a road, right? So what about road surface? Yeah. What happens if we've got gravel road versus asphalt road? Okay.
Gravel road will wash out.
Gravel road has more potential to wash, but
They can soak into the gravel.
it can also soak into the gravel, right? Whereas an asphalt road, what's that going to do?
Run off.
Okay, it's going to cause more runoff because it's impervious, so the water's going to continue to run across the road, which could create problems on down, you have problems with freeze and thaw and all that sort of stuff. Okay, does that make sense? And expense, of course. Everything is going to be cost more based on construction. What's another application for this? Okay, so here's the scenario. We have a doctor's office, okay? We're going to build a doctor's office right here. Right now, what do we have right here out in this field? We've got a piece of property, and we're going to build a building right here. Okay? So what's the first thing we have to do in terms of surveying? Okay, so we're going to run out, we're going to do a topo of what? Okay? So if that's the actual footprint of the building, and this sand, the entire sandbox represents the project, the overall project, and it looks just like this when you get there, what do you got to do? Well, go back to the topo survey. What do we got to do? Okay, so right now with nothing being on that land, where's that water going right now, primarily? Kind of where the building is. There's probably going to be some water down here because we've got a low spot, right? Although it doesn't show that way. Okay. But what we have to do is determine, okay, where's that building need to set? Okay. And what do I mean by that? Okay, so not only its horizontal position this way, but its vertical position this way, right? So when you go out to do topo, what are we going to do? Walk me through this. First off, let's ask this question. Where's a logical place to set your base station? Up there on the hill, right? So you get your base station set up. Of course, we're going to do this topo with GPS. We set our base station up on that high spot, and then what? What would be the first thing that you would probably want to do if this sandbox represents the property? Locate the boundary itself, okay? So you locate that boundary, you make sure that it's good, right? And some of that will be taken care of in the office as well, right? You're out there to gather the information. So you gather the property information, now what? Okay, so you locate stuff. How do you know where sewer and water are? Okay, so sewer, you might have manholes. What about water? Maybe. What about if you don't have fire hydrants? How am I going to find the utilities to locate? Anybody ever heard of the number 811? Okay, who are we going to call? Okay, you're going to call some sort of a dig line or some sort of a utility locate company. It's going to come out, and what are they going to do?
Put little marks.
Okay, hopefully they've been called before you get there, right? So they're going to paint marks on the ground representing what?
Where their lines run out, all the different lines.
Okay, how do you know which one's water and which one's power and which one's telephone, which one's sewer and which one's gas? Okay, there's a color scheme, right? There's a color scheme, and they're going to paint them based on what's out there. Then whose responsibility is to put that on the map? Okay, we're going to locate that as we locate our property. Okay. All right. So now that we locate our utilities, now what are we going to do? What's the critical components in that topography that would allow us, or that would be required to collect? Okay. So for those that have some experience, how would you do it? Grid. Okay, maybe a 50-foot grid, which means that I'm going to take a shot every 50 feet. What happens though if my grid is, if this is 50 feet from, let's say we're 50 feet from here to there, and I take a shot here, and I take a shot here. Okay, so just because it's a 50-foot grid doesn't mean that I can only take it on a 50-foot. I've got to take one on the top of this as well, right? I've got to locate the top of this ridge. Got to locate the top of this ridge, and I've got to locate down in between. So grid is critical, but not in concrete, right? You've got to be able to move around to say, well, I've got to get the things that mean the most. Okay. What about the bottom of the pond down there? Yeah, you're going to get as many. How long does it take to take a shot with GPS? Not very long, right? So what's the rule of thumb then? Okay. If there's ever a question whether I should get it or not, what's the answer? Get it. I mean, it doesn't take any more storage, really, right? So if you ever have a question on what to take, just pick it up, right? We can go through and decipher that or scramble them up later, okay? Or de-scramble them. Okay, so we've gone out there. Now we've taken a topo. Where does it go from there? Okay, so you're going to bring it back in to the office, and either yourself or someone else is going to create some sort of a map, right? So if it's you, collecting the data is probably not a big deal, right? Because you know what you've collected. What if somebody else is going to draw it up? Okay, they've got to be able to understand what codes, what you're calling things, right? Tops and toes and bottoms and ditches and utilities, okay? So you've got to be able to decipher, they've got to be able to decipher what you're trying to tell them. It's got to do the design that says, well, the building's going to set right there, but where's it going to set in terms of elevation? And how are they going to determine that, basically? They're going to take your topo and say, okay, well, if I've got to raise that building so it doesn't flood, then I'm going to have to move some dirt somewhere else, right? So that's one way to look at it. The other thing they could do is move some dirt around, right? Where's the expense in a construction? Yeah, those cuts and fills, moving that dirt around. But depending on what they need to do, they could lift. If they lift that building up, can they just lift it? What are they going to have to do? Okay, so here's the site. The building's where it's depicted to go. It's going to be right there. So somehow we've got to build this up, and we've got to take dirt from somewhere. Okay, why do you say on site? Yeah, anytime we start going off site to bring material in, we're going to have problems, right? Okay, got to move that dirt, right? And anytime you move dirt, it's going to take time and money. Okay, so I'm going to flatten this out. Okay, now is my building pad higher now than the rest of my property? How do we know that? And what about what else about the contour, the overall contour? What did we decide in terms of color? Okay, what's the highest? White. Okay, so what we've said is, okay, now we've got a building pad that's higher than the rest of the surrounding area. Is that a good thing? Okay, that is a good thing, because when water comes, we don't want it to go in the building.